Mean time to repair, MTTR, is a key performance metric used to measure the average time required to repair a system or component after a failure or malfunction. It is an essential metric in maintenance management, helping organizations assess the efficiency of their repair processes and their ability to minimize downtime. By reducing MTTR, businesses can enhance productivity, reduce costs, and improve the overall reliability of their equipment. Mean time to repair, MTTR, is the average time required to diagnose and fix a failure in equipment or machinery. It typically includes time spent identifying the problem, diagnosis, time spent repairing the system, actual repair time, time to return the equipment to full functionality, testing and restart. MTTR is expressed in hours or minutes and is typically calculated by dividing the total time spent on repairs by the total number of repairs performed over a certain period. Who is involved in calculating and improving MTTR? Maintenance teams, maintenance technicians, engineers, and repair personnel play a central role in repairing the equipment. Their efficiency directly impacts the MTTR. Operations and production managers. These professionals coordinate repairs and plan maintenance schedules to minimize disruptions and ensure that repair times are reduced. Data analysts. In larger organizations, data analysts track, record, and analyze MTTR data to identify trends and areas of improvement. Vendors or external technicians. For complex equipment, external service providers may assist in repairs, and their performance will also contribute to the MTTR. When is MTTR measured and applied? During equipment failures, MTTR is measured every time a failure occurs and a repair is performed. It helps track how efficiently the issue was resolved. At scheduled intervals, MTTR can be analyzed over time, typically monthly or quarterly, to monitor trends and improvements. During preventive maintenance planning, understanding MTTR helps in scheduling maintenance activities and ensuring that critical repairs are done in a timely manner without disrupting production. Where is MTTR measured and used? Manufacturing plants. In industrial settings where machinery and equipment are essential for production, MTTR is crucial in measuring repair efficiency. IT and data centers. In sectors reliant on servers, networking systems, and hardware, MTTR is used to monitor the downtime and repair effectiveness of IT infrastructure. Automotive and transportation. For fleets of vehicles, MTTR is used to track repair times and maintain high operational availability. Energy and utilities. MTTR is important in power plants and utility sectors, where breakdowns can lead to significant downtime and impact service delivery. Why is MTTR important? Improved efficiency. By measuring and optimizing MTTR, organizations can identify bottlenecks in their repair processes and improve overall efficiency. Cost reduction. Faster repairs mean less downtime, which reduces the costs associated with lost production or service. Customer satisfaction. In industries such as manufacturing, transportation, and IT, MTTR directly impacts the ability to meet customer expectations. Quick repairs lead to minimal service disruptions. Reliability. A lower MTTR indicates that a company is effectively managing and maintaining its assets, contributing to more reliable equipment and systems. Data-driven decision-making. Tracking MTTR allows organizations to make data-driven decisions to optimize their maintenance strategies and improve system reliability. How is MTTR calculated and improved? Improvement strategies. Staff training. Ensuring that technicians have the right skills to quickly diagnose and repair issues. Improved diagnostic tools. Using advanced diagnostic tools and techniques to identify faults faster and more accurately. Spare parts availability. Keeping an inventory of critical spare parts ensures faster repair times. Preventive maintenance. Implementing regular maintenance schedules helps prevent breakdowns, reducing the need for urgent repairs. Process optimization. Streamlining repair processes and implementing best practices can cut down the time required for repairs. Predictive maintenance. Leveraging data from condition monitoring tools allows companies to predict potential failures before they happen, reducing unplanned downtime and repairs. In conclusion, machine breakdown reduction is an essential component of operational efficiency and cost control in industries that rely on machinery. By using predictive maintenance, condition monitoring, and root cause analysis, Businesses can reduce downtime, improve productivity, and prolong the life of equipment, leading to greater profitability and a safer working environment.
This quiz is designed to assess an individual's commitment to learning about mean time to repair, MTTR, a critical metric in maintenance and repair management. By answering these questions, you'll gain insight into your interest, knowledge, and dedication to improving MTTR and enhancing repair efficiency in your workplace. Instructions: answer the following questions honestly to gauge your understanding and commitment to improving MTTR. There are no right or wrong answers. This quiz is designed to provide insights into your approach to learning about MTTR and its impact on your operations. 1. How familiar are you with the concept of mean time to repair, MTTR? A. I have never heard of it. B. I have a basic understanding but don't know much. C. I know what it is and understand its relevance. D. I am very familiar with MTTR and actively track or use it in my work. 2. How often do you analyze or track MTTR in your workplace or industry? A. I don't track MTTR or consider it important. B. I occasionally look at MTTR, but I don't track it regularly. C. I track MTTR occasionally and use it to assess repair performance. D. I consistently track MTTR and use it to improve repair efficiency and reduce downtime. 3. When a machine or system breaks down, how quickly do you assess or initiate the repair process? A. I usually wait for someone else to handle the repairs. B. I try to assist with the repair, but I don't take the lead. C. I initiate the repair process when possible, but I may need more knowledge on improving repair times. D. I quickly assess the situation, initiate repairs, and strive to minimize MTTR by following efficient processes. 4. How comfortable are you with using data and metrics, such as MTTR, to improve maintenance operations? A. I don't use data or metrics in maintenance management. B. I'm starting to recognize the value of data, but I'm not fully comfortable using it. C. I use data occasionally to identify areas for improvement in repairs. D. I actively use MTTR data and other metrics to identify inefficiencies and improve maintenance practices. 5. Have you ever participated in training or learning programs focused on repair efficiency or reducing MTTR? A. No. I haven't participated in any related training. B. I've attended a basic session but haven't focused on MTTR specifically. C. Yes. I've participated in training on maintenance efficiency, including MTTR, but I'm still learning. D. Yes. I actively seek out training opportunities on MTTR, repair processes, and best practices for reducing downtime. 6. When you are involved in repairing machinery or equipment, how often do you consider ways to reduce repair time, MTTR? A. I don't usually think about repair time. I focus on getting the job done. B. I occasionally think about ways to reduce repair time but don't always prioritize it. C. I often look for ways to streamline repairs, but I may not have all the resources or knowledge. D. I consistently think about repair time and actively implement strategies to reduce MTTR during repairs. 7. How important do you think reducing MTTR is for the overall success of a business or organization? A. I don't think it's a significant factor in business success. B. It's somewhat important, but other factors matter more. C. Reducing MTTR is important, as it helps minimize downtime and improve efficiency. D. It's crucial for business success. Reducing MTTR directly impacts productivity, cost savings, and customer satisfaction. 8. How do you approach continuous improvement when it comes to reducing MTTR? A. I don't focus on continuous improvement in this area. B. I try to improve but don't have a structured plan for reducing MTTR. C. I occasionally make changes to improve repair efficiency, but I don't always measure MTTR to gauge success. D. I actively work on continuous improvement by analyzing MTTR data, applying lessons learned, and refining repair processes. 9. How often do you collaborate with others, team members, vendors, etc., to optimize repair processes and reduce MTTR? A. I rarely collaborate with others on repair processes. B. I collaborate occasionally, but not consistently. C. I regularly collaborate with others to improve repair processes and minimize downtime. D. I actively collaborate with team members, vendors, and experts to continually reduce MTTR and enhance repair efficiency. 10. Do you think MTTR can be effectively reduced by focusing on preventive maintenance, predictive maintenance, and data-driven decisions? A. I'm not sure how these methods relate to MTTR. B. I think they might help, but I'm not convinced they have a big impact on MTTR. C. I believe they can help reduce MTTR, but I still need more experience with these methods. D. Yes. I believe strongly in using preventive and predictive maintenance, as well as data-driven decisions, to reduce MTTR and improve repair efficiency. Scoring guide. Mostly A's, 1 to 2, low commitment. To improve your effectiveness in maintenance management, it's a good idea to start learning more about MTTR and how it can be optimized to reduce downtime and improve operations. Mostly B's, 3 to 5, moderate commitment. You have a basic understanding of MTTR and its importance but may not be fully committed to tracking and reducing it. Consider focusing on gaining more practical knowledge. Mostly C's, 6 to 8, high commitment. You are actively learning about MTTR and working to reduce it in your operations. With continued focus on continuous improvement and leveraging data, you can become an expert in minimizing repair times and boosting efficiency. Mostly D's, 9 to 10, exceptional commitment. You are highly committed to reducing MTTR and improving repair processes. Your proactive approach and willingness to learn and apply new techniques make you a valuable asset in optimizing repair efficiency and minimizing downtime. Next steps. By completing this quiz, you've gained insight into your current commitment level to learning about mean time to repair. Based on your results, consider setting a goal to explore MTTR in more depth. Whether you're new to it or have experience with it, identifying areas for improvement can help you better contribute to process improvement and organizational success. Send your score to the email listed in the comments section and become part of our ecosystem for further future developments.